Today we're going to go through the global human and ethical impacts. And this is a part of a capstone project with virtual teams. So everything we do as engineers does have an impact on the global human and ethical sides of life, right? So what we design, you can see the garbage bags in this picture. Are they going to end up in the trash? Are they going to end up in a landfill? What about the smokestacks we see? What kind of pollution is going to be created from our designs? The impacts that we have, human impacts. So throughout time, humanity has used natural resources such as animals, plants, and innate materials for its survival, consumption, and enjoyment. This often takes a toll on society, and we often take this for granted. Many times, short-term monetary gain is considered a priority over the long-term health of our Earth. Globally, our population continues to grow at an exponential rate, and this continues to require change in human needs and wants. And for energy purposes, non-renewable resources are becoming more and more scarce. So ethics. Ethics is a set of moral principles or values, a theory or system of moral values. The discipline dealing with what is good and bad and with moral duty and obligation. So actually in college, for my engineering courses at UIC, there was a whole semester class, a 3-credit class you took on ethics, junior or senior year. And it was really quite interesting to take. One of the new things now this was when I was in college, but that came up is ethically, as an engineering company, you had to stop taking gifts from companies selling their products. So it wouldn't be ethical to take an iPad from a company selling a stormwater management system, because then that would mean I would likely design their product more often because they were kind of paying me off to do that. So that was a new thing that got put into the code of ethics for engineers when I first started working. So when we are designing things, the situations and decisions you make, you really do have to think of, is this morally correct? Like, does this follow the engineering code of ethics? So when we look at these pictures, you can ask yourself, what are the ethical consequences that are suggested? So we have a car, we have some smokestacks, and we have the sun. I'll just focus on the car. So when I look at the car, you think of ethical consequences would be, what are the emissions? What kind of materials were used to build that car? What kind of factory was used to build that car? What kind of toxic outputs come from that process? What about the gas intake? How much gas is consumed? Is it an electric car? So lots of questions could come up regarding long-term effects from that auto. So the steps in resolving an ethical design decision. So number 1, we would talk about moral clarity. Identify the relevant moral values. 2, conceptual clarity. Clarify any key concepts. 3, just the facts. Obtain all relevant information. Sometimes when we talk about number 3, your emotions can get involved, or your whatever stance you have on a project. So you try to eliminate those just to look at just the facts. Number 4, informed about options. Consider all genuine options and alternative solutions. And 5, well-reasoned. Make a reasonable decision. So a design analogy is for engineering design as a metaphor or model for thinking about moral decision-making in general, not just within engineering. So like design, moral choices often involves alternative permissible solutions to any dilemma we have. So it really is taking a step back, not being reactive, and actually taking some time to think so that you can react in a thoughtful manner. So the next concept is the product life cycle. So this is an important concept to think about. So if we look through this system here, step number 1 is to raise and extract. Number 2, the process. 3, we manufacture. 4, we use the product. And 5, we dispose of the product. And we're going to talk about each one of those steps. But you can see this is a constant circle of a product life cycle. So raise and extract is when all consumer products begin their life cycle with a dependence on the natural environment. So some form of energy is always required to extract the natural resources from the earth or its atmosphere. The process is taking raw materials, and when they are processed or refined, energy is required for the processing and refining. We manufacture, additional energy is then required as the processed or refined materials move through the manufacturing and assembly process. Then we would use our product, so the consumer would use our product, it's transported to stores, and we would purchase the product. And the product remains at this stage as long as they are usable or repairable. When the product is no longer in use to us, we get rid of the product. So does that go into a landfill, the garbage? Does that get recycled? Is that something that we can resell? The EPA guidelines. So EPA stands for Environmental Protection Agency. This is an important acronym to know. This organization's mission is to protect the human health and the environment. The EPA works to develop and enforce regulations that implement environmental laws enacted by Congress. The EPA is responsible for researching and setting national standards for a variety of environmental programs. Another key term is OSHA, O-S-H-A. In short, people call it OSHA, and this is Occupational Safety and Health Administration. OSHA's mission is to assure the safety and health of Americans' workers by setting and enforcing standards, providing training, outreach, and education, establishing partnerships, and encouraging continual improvement of workplace safety and health. So we actually at Hoffman and in District 211, we actually have OSHA representatives that come to the school and they work with Mr. Harlan, and they go through each classroom space, each gym space, each office space, and look for any workplace hazards. And then they would tell us as a community what we need to do to fix that. You can get fined if you break any OSHA guidelines. As an engineer, OSHA would come to my project sites to make sure that we were providing a safe working environment for the construction workers, that when we were building trenches to put pipes in, that we had the proper spacing, that we had the proper slope on the walls, proper devices to use. So OSHA is, like, in terms of civil engineering, I can speak to directly, is very highly involved. So next, let's talk about recycling. So products made from recycled materials are really, I wouldn't even say a new like key item, but it has been. And you can see the tire, this bottom picture that has the black grit in it. That would be recycled tires, and oftentimes you'll see those used at a playground now. Instead of mulch, you would see recycled tires used as a base. And why we recycle, I think you guys are probably could give me a better speech than I can give you on this. But of course, it's to protect our environment, protect our natural habitats, and to make sure our world is, we leave it in a better place for our own children. So the process, products to be recycled, the consumer role, collector's roll, remanufacturing a process, and a finished product. Key to recycling is the consumer, so it really is dependent on us. If you think at Hoffman, we have those recycling bins, but we actually, as a school, only recycle the paper. So anytime a can gets put into that recycling bin, that whole recycling bin now is just trash. So it is about sorting your recyclables as well. And really, like, the knowledge is power for the consumer, knowing how to recycle. And this little infographic here would walk us through plantation to paper and paper to paper. And when we talk non-recyclable items, what can we do? Can we dispose of these properly? Do we have to dispose of them differently in terms of like paint? You have batteries. Just being knowledgeable on how to correctly dispose of things helps the environment. All right, and that is our notes and our information on global, human, and ethical impacts.